A different type of curve that can be fit into the graph of the dataset is an exponential curve, which requires a different approach. Check it out here in Numerical Solutions 2CE Problems. The first example has 10 data points of regular x intervals. The task is to find the equation of the best fit exponential curve. But what is the exponential curve equation? We use y as equal to a raised to x times b. As we are to solve for x and y first, the challenge is to bring down the exponent x. That can be done by using logarithms, making log of y as equal to log of a raised to x times b. Through the rules of logarithms, expand the log of a raised to x and b by addition. So the equation now becomes log of y as equal to log of a raised to x plus logarithm of b. Then by power rule of logarithms, we bring down x, making the equation log of y as equal to x logarithm of a plus logarithm of b. With this format, log of y is capital Y. Logarithm of a is taken as capital A, and log of b is capital B. Then, we get the linear model of y as equal to ax plus b, where y, a, and b are modified. X remains as is. From the dataset having 10 points, the first group has 5 points from x of 1 to x equal to 1.4. There is also an added column for capital Y, which is the logarithm of y. Add the 5 x values and get 6, then divide these into 5 to get 1.2. For capital Y, take the logarithm of each y value. That is, logarithm of 5.68 is 0.7543. The logarithm of 8.05 is 0.9058. The log of 10.25 is 1.0107. The log of 11.97 is 1.0781. And the logarithm of 12.68 is 1.1031. Add all these together to get 4.852, which when divided by 5 gives 0.9704. With the average of x and capital Y taken, the first equation is completed as 0.9704 as equal to 1.2a plus b. The second group contains the other 5 data points from x of 1.5 to x of 1.9. The summation of all x values is 8.5, and the average is 1.7. Capital Y is also computed individually. The logarithm of 14.03 is 1.1471. Then that of 15.46 is 1.1892. The logarithm of 17.08 is 1.2325, and the log of 18.52 is 1.2676. The logarithm of 19.86 is 1.2980. Take the summation of all capital Y values and arrive at 6.1344. If this is divided by 5, Y average is 1.22688. With the table completed, the linear equation for the group is then 1.22688 as equal to 1.7a plus b. This is equation 2. Again, by method of elimination, subtract equation 3 from equation 4 to take out b. 1.22688 minus 0.9704 is 0.25648. Then 1.7 minus 1.2 is 0.5a. A is then taken as 0.51296. Again, capital A is equal to the logarithm of A, which is the needed parameter in the exponential equation. With logarithms, use the opposite operation, that is with e. A is then e raised to 0.51296, which gives A as 1.6702. On the other side, plug the value of capital A into equation 1 to have 0.9704 as equal to 1.2 times 0.51296 plus b. Capital B is then 0.354848, and this is also the logarithm of b. So with the same procedure of using exponents, b is e raised to 0.354848, making b 1.4260. With the two components already figured out, the format of y as a raised to x times b would turn out as y as equal to 1.6702 raised to x times 1.4260 relative to the dataset. The second example has 11 data points, where the first group will have 6 points and the rest go to the second group. The first group of 6 coordinates contain x of 0.2 to x of 1.2, which when added all together give 4.2, and when divided by 6 will give the average of 0.7. Now let's solve for capital Y, which is the same as logarithm of y. For y of 21.56, the logarithm is 1.3336. For 23.47, capital Y is 1.3705. Then the logarithm of 24.98 is 1.3976. The log of 26.07 is 1.4161. For 28.12, capital Y is 1.4490. And for y of 29.84, the logarithm is 1.4748. Add these 6 capital Y values and get 8.4416. And the average is 1.4069. So with the linear format of A and B, the first equation is 1.4069 as equal to 0.7a plus b. For the second group, x values start at 1.4 way down to 2.2. The summation of x is 9, and the average is 1.8. The values of capital Y are solved as 1.4989, 1.5168, 1.5373, 1.5536, and also 1.5673, all of which are solved as the logarithm of y. Take the summation and get 7.6739. Then divide this by 5 to get the average as 1.53478. Thus, the second equation is known to be 1.5348 as equal to 1.8a plus b. With the method of elimination, subtract equation 3 from 4 to eliminate b. That is, with 1.5348 minus 1.4069 as 0.1279. 1.8 minus 0.7 also gives 1.1a, where a is solved as 0.1163. This is also the logarithm of a. So a is solved as e raised to 0.1163, and a is simplified as 1.1233. Back to capital A plugged into the first equation, which makes it 1.4069 as equal to 0.7 times 0.1163 plus b. B is then solved as 1.32549. This is also log of b. So b is then e raised to 1.32549, which is simplified as 3.7640. The exponential function for the best fit curve is then y as equal to 1.1233 raised to x times 3.7640.